Imagine a breathtaking cosmic concerto, performed by an endless array of stars, planets and moons, all harmonizing perfectly. Yet within this celestial ensemble, one particular section has intrigued astronomers for ages. Exoplanets. These natural worlds exist beyond our solar system, hidden deep within the vast expanse of the Milky Way. What might astonish you is that, among these countless celestial bodies, there lies one so strikingly similar to Earth, so tantalizingly familiar that it could very well be our planetary twin. Let us journey into the intriguing world of Proxima B, a planet located a mere 4.2 light-years from Earth. The James Webb Space Telescope is transforming how we approach the search for and comprehension of these mysterious worlds. Envision for a moment that your thoughts wander through the vast astronomical expanse of the Milky Way, a galaxy hosting more than a quadrillion exoplanets. That's one followed by 15 zeros. To visualize this, imagine that each exoplanet were the size of a grain of sand. Not only would this fill the Grand Canyon, but it would be enough to construct a new geological wonder, Earth's version of Grand Canyon 2.0, in length. What's even more astonishing is that around 20% of these distant worlds have been identified as Earth-like in terms of their geological structure and atmosphere. This means that for every 5 exoplanets, one could resemble our planet. But the story doesn't end here. Accompanying these planets could be another quadrillion moons, rocky satellites akin to Earth's own, engaging in gravitational dances with their parent planets. If you're hoping for the discovery of another body in space that could harbor life, or perhaps one that could, then the universe provides endless opportunities. Now that we've begun to unfold the immense scale of the cosmos, it's time to introduce the master artist, capable of painting its intricate details, the James Webb Space Telescope. This cosmic investigator, holding a telescope lens in place of a standard magnifying glass, outshines even the most sophisticated optical instruments. 6.5-meter primary mirror, 2.7 times larger than Hubble's, has the capability to detect even the faintest star flickers, billions of light-years away, analyzing the planets that orbit them. But the James Webb is revolutionary not only for its unparalleled observing power but also for its advanced technology, which includes infrared sensors and spectrographs. These tools can do more than simply observe. They can analyze the unique light signatures that are released or reflected by celestial objects to decipher their atmospheric conditions, composition, density, and even mass. As space forensic scientists, they can determine if a planet contains water, oxygen, or even organic compounds. The James Webb Space Telescope is not just an upgraded version of Hubble. It is a monumental leap forward. If Hubble's discoveries left you astonished, prepare for an even more spectacular series of revelations as we continue to explore the intricate landscape of the cosmos. One star in particular beckons our focus: Proxima B. Since its discovery in 2016, this mysterious planet has become the protagonist of a cosmic tale full of complexity and paradoxes that have intrigued astronomers and researchers. Like, what makes Proxima B stand out? For starters, it is located in our cosmic neighborhood, just 4.2 light-years away. To put this in perspective, if you could travel at the speed of light, you'd reach Proxima B in just over 4 years, the same amount of time it takes for a presidential term to conclude or for your favorite TV show to become outdated. But the proximity of this planet is important for more than just practical reasons. It lies within a universe that stretches across 93 billion light-years. So finding a planet so close yet so full of scientific potential holds promise. Like discovering a diamond in a mountain-sized pile of stones. The diamond could hold vital secrets about life and our place within the grand scheme of the universe. Proxima B's allure isn't solely based on its proximity. Astronomers on Earth think it might not only resemble Earth but could even be Earth's twin, Earth 2.0, positioned in the so-called habitable zone of its star, where the circumstances are just right. Not too hot, not too cold. It may offer the possibility of drinking water, waterfalls cascading down cliffs, vast rivers winding through alien landscapes, and oceans as mysterious and deep as Earth's Mariana Trench. However, before we let our imaginations run wild with thoughts of vacationing on Proxima B, we must consider some of its peculiarities. For instance, one day on Proxima B lasts an astonishing 11 Earth days. Imagine sunrises that unfold slowly, heralding a new day, followed by extended sunsets stretching into glorious hours, scenes that photographers dream of. While this might sound like a dream come true, it poses intriguing questions about the planet's climate and habitability. Would our human biorhythms adapt to this unfamiliar light and dark cycle? Would we need to eat more on Proxima B? Could we sleep in the same manner as we do here on Earth? Life as we know it would be both strangely familiar and perplexingly alien. Nature seems to present us with a riddle wrapped in a mystery. Could the civilization of Proxima B be comparable to ours? A test that challenges our presumptions regarding what constitutes a habitable planet. But how can we gather accurate, reliable data about a world we've never visited? The James Webb Space Telescope deploys all of its abilities to respond to this question, serving as an adaptable research facility in space. Thanks to its cutting-edge technology, astronomers can not only observe distant planets but also analyze them with advanced tools. Through infrared sensors and spectrographs, the telescope can study the light emitted and reflected by these far-off worlds. By analyzing the specific wavelengths of light that are absorbed or released by various elements or compounds in a planet's atmosphere, scientists can conduct a remote biopsy of these celestial bodies. This allows them to determine atmospheric pressure, density, and the potential presence of life-sustaining elements like water, organic molecules, and oxygen. The James Webb Space Telescope isn't just another tool for observation. It gives us access to analytical genius, transforming speculations into scientific facts. It expands our understanding of the universe and reshapes our perception of what might exist beyond our home planet. Just when we thought we had unraveled all the secrets of the cosmos, a surprising twist emerged. Researchers using the James Webb captured something extraordinary from Proxima B, a signal so strange and complex that it swept through the academic world and social media, sparking discussions about the potential for extraterrestrial life. This electromagnetic emission was unlike anything observed before, so intricate and patterned that it might suggest the presence of an advanced civilization. For a moment, humanity's collective heartbeat appeared to become entangled in the possibility that we might not be alone in the universe. But just as quickly as the signal appeared, it vanished, leaving behind an eerie silence, a surge of speculation, and a trail of unanswered questions. Was it merely a fleeting cosmic glitch, a quirk in the fabric of space? Or could it have been a whisper from a distant intelligence? Perhaps a coded message, or even the echo of an ancient civilization reaching out across time. This lone signal has cast a profound veil of mystery over Proxima B, transforming it from a curious candidate for habitability into the centerpiece of cosmic intrigue. The possibilities are thrilling. Could this be a component of a more elaborate narrative, one that connects us to a wider galactic community? While certainty remains elusive, one thing is clear: the mystery deepens our resolve. It fuels not just curiosity in science, but a profound human desire to connect with something beyond ourselves. And the story doesn't end there. As technology advances, the James Webb Space Telescope, no longer just a passive observer but a celestial sleuth, is being adapted by forward-thinking scientists into what can only be described as a galactic night vision device. Their mission: to scan distant exoplanets not just for signs of life, but for artificial illumination. Yes, light, streetlights, cities, metropolises glowing in alien twilight. Imagine the sheer wonder of it. A bustling alien civilization radiating its energy into the cosmos, visible not by its biological markers, but by its technological signature. A skyline gleaming across an exoplanet's dark side. Artificial luminescence shining like a beacon through the void. Sounds like science fiction, but it's quickly becoming science fact. Such a discovery would be historic. Detecting artificial lighting would not only confirm intelligent life beyond Earth, it would suggest an interconnected universe where life is not an anomaly, but a pattern. A cosmic refrain repeating across the stars. And what would that mean for us? It would reshape philosophy, religion, politics, and science in a single breathtaking instant. We would no longer be the lonely children of Earth, but part of a vast, perhaps ancient, galactic lineage. It would raise additional questions, more profound than any we've asked before. How do we communicate? What can we learn from them? And how do we define us, once we know there is also them? But for now, we remain on the cusp. The James Webb Space Telescope continues to guide our gaze deeper into the night, revealing star systems, analyzing atmospheres, and unearthing secrets long buried in the silence of space. Every new spectrum decoded, every light curve studied, brings us closer to answering the ultimate questions. Are we alone? What else is out there? And could we ever establish another world to call home? This is more than exploration, it's revelation. As we stand at the edge of this extraordinary era, let us not ignore the fact that the universe is not just vast. It's alive with mystery, waiting to be unraveled. And with the James Webb Space Telescope lighting our path, we are not just observing. We are discovering our future. One star, one signal, one world at a time.